and welcome to another video. Today it's Advent of Code. It's that time of year again, and I really want to see your solutions, so leave those in the comment section down below. If you want to support the channel, there is a link in the description to different affiliates where you can get great deals on things, and there's also a donation link if you want to donate a coffee to me in order to improve the quality of this channel. Good morning. We're back in this studio again, and I'm not sure if I brought the conference flu back, but let's see what the next is. Day 7. Bridge repair. The historians take you to a familiar rope bridge over the river to the middle of the jungle. The chief isn't on this side of the bridge, though. Maybe he is on the other side. When you go across the bridge, you notice a group of engineers trying to repair it. Apparently it breaks pretty frequently. You won't be able to cross until it's fixed. You ask how long it will take. The engineers tell you that there needs to be a final calibrations, but the young elephant has been playing nearby and stole all the operators from their calculation equations. They could finish the calibrations only if someone could determine the test's values possible be pronounced by placing any combination of operators in their calibration equations. Your puzzle input, for example, and we have it there. Each of them represent an equation. The test value appears before the colon, and each line is your job to determine whether the remaining numbers can be combined with operators to produce the test value. The operators are always evaluated left to right, not according to the precedent rules. Furthermore, the numbers in the equations cannot be rearranged. Glancing into the jungle, you can see that elephants are holding two different types of operators: add and multiply. Only 3 of the above equations can be made true by inserting operators. And then we have the different positions there. And it can only be solved one way. The engineers just need the total calibration result, which is the sum of the test values, just equation that can possibly be true. In this above example, the sum of the test values for the 3 equations listed is above. So this is some kind of recursion operation, I guess. So let's see. First, we need to parse these lines. So we create this for loop again with string, line, lines. And then we have first in the line we will take the line and split it with colon. So we get a string, let's see, let's just call it val for now, or array. And in this array, the first part is the result, integer, result, int result, integer, parse int. So that's the first part. And I don't think that we have, let's see, do we have things that are huge? Yeah, we have a couple of things that are larger in size. So maybe we want this actually to be a big integer. New big integer, and then we just have that. Then we have a big integer sum, which is big integer 0. So what we now want to figure out is if this result should be added to the sum. So what I want to do is create a function that returns a boolean add, check calculation, like that, and that if add, then sum add result. That is pretty much it. Sum equals to sum add result. We could also add the parentheses to make it even more clear. And then we will take the sum and print it out. So this is the workflow. The calculation needs the values. So here we will take all of the values from this here. And I don't think there are any one of these that are required to be big integers. So those could probably be integers. So let's see if we can take this array, number 1, and first off trim it so we don't have any extra spaces, and then split it by space. Then we will get the operands, or something like that. Not the operators, the operands. And then we need to take those and make those into integers. So operand string, and then operands, new integer, and we take the operand string length as our length there, and we can take I wonder if you can just do like this, operand string map, and then the function here would be a integer parse int a. Is that possible? No, I don't want a string object. I want an integer. Let's do it the old-fashioned way with a for loop. It's probably some way you can do that, but as I can't look it up, I don't know. Maybe I'll look it up afterwards and see if I can figure out how to stream that with a map. It should be possible, right? Integer, parse int, operand string, and I. So now we have a list of operands that we want to do. So that is what we want to calculate. We want to have the result that we want to find out. And we can have either plus or multiplications, or sums or multiplications. So let's create this function here. And then we will take the two first values and multiply those together. So we will create a new int array here. No, they can't be int arrays. They need to be big integer, because the result can be big integer. Or we can use we can have all the operands as they are, and then we can just have a count here. So and then that count big integer count big integer 0. So we start there, another big integer here that is a count. And then we also need to have an integer index where we actually are. Index. And this should start at 1. So the second value. And then this big integer should actually be value of the operand's first value. So then we will do something with the second value, right? So then we have big integer someone is equal to, so the first thing we can have is the count value added to by the big integer value of operand's index. So that's the first sum. And the second sum that we could have is multiply. So that there we have two values. Then we will do check calculation of those two. So we will do operands, index plus plus, sum one, result. Like that. And then sum two, result. So those are the things that we want to continue doing. If the index is equal to operand's length, then we need to return a result. Something here. And check one, and we can have check two of these, and we will return check one or check two. So either or could be true, and then we will return a true. So now we only need to figure out when we reach the end of the operand list, have the count become the result. So the return value here should be count equals to, I wonder if equals works well with big ints, but I guess it will, equals to the result, and then we will return that. So I wonder what we get if we just run this. We get an array out of bounds exception, of course. There, okay. Why do we get there? Because if we were at the length of the operands, then we would stop, right? So we shouldn't get that far. Index of length 2. Strange. Yeah, we are doing this. Let's say index plus plus. Of course. So we can't do plus plus the index on both accounts. Now we got 3749. And it's correct. So my weird calculation here seems to work. Let's see if we get something when we run the big one. We got a huge number. Could that be the correct puzzle? So let's see. Put that in here. Yes! You get a gold star. I get a gold star. Everybody gets a gold star. We solved the first one. Now to the more complicated one. The engineer seems concerned. The total calculation result you gave them is nowhere close to being within safety tolerances. Just then you spot your mistake. Some well-hidden elephants are holding the third operator type, of course. The concatenation operator combines the digits from the left and the right inputs into a single number. For example, 12, 345 would become that. All operators are still evaluated left to right. Now, apart from the three equations that you made through using only addition and multiplication, the above example has three more equations. What could be true by inserting the operators? So that could become true if you combine those two, and that could become true if you combine that, okay? Adding up all 6 values before using that, you would get that result. Using only the new knowledge of the elephant hiding spots, determine which calculations could possibly become true. Is their total calibration result. Okay, I think that should be pretty simple as well, because we only need to have a third sum here, like that. And here we need to take the count to string and add the operands. I guess you could just do this, and then you have plus operands index. So that would create a string, big integer. We just put that into a new big integer, like that. And that would become our third sum, like that. And let's check if check 3 is true as well. So now we just added to that. We will have the test value again. Let's run it. We got 11387. That is totally correct. Let's try it with running the full. It takes a while, so this was more complicated. We get a huge number. Let's put that in. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. So today's was a little bit simple, but it's because we are using big integers, which can handle really large numbers, and they are using strings in the background. So we were very fortunate that we had that in the Java language, making things much simpler for us. So what we did here is that we have lines that we go through. We have a sum that we start at 0. We take each line, we split them up with comma to get the part that are the sum that we want to find, or the result we want to find, and the actual operands. And then we take this as a result here. We split up all the operands, so we get those in a string list. We switch those over to so we have numbers instead, easier to work with. And then we take the first operand and put into our count, something that we want to count up and see if we can reach the result in some way. Then we create this function that is recursive, that takes the operands, starts at index 1 because we have already added index 0, and then we put in count and the result we want to end up at. And if we are able to add these up, if it's possible to do this, then we will add that up to the result, and we will print that out. When it comes to check calculation, if we are at the end of the list, we will say that, okay, we don't want to do more, we just want to check if the count is the result. Otherwise, we do 3 different operations here. We do an add operations with the next operand, we do a multiply operations with the next operand, or we do a string concatenation of the third operand, next operand, and then create a new big integer of that into our third sum. We increment our index so it will take the next number, and then we run 3 checks on the next sum here, and we will end up with something that we can check if any of these calculations are true, then we have reached our sum. So this was day 7. It wasn't that hard. I hope that you liked this video. Share it with your friends and colleagues. I really want to see your solutions. Leave those in the comment section down below. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.